Let's apply convolution theorem. Um, let's look at the first problem. Find inverse Laplace of 1 by s plus 2 and s plus 4. In other words, we will have to find the function whose Laplace is this. So let's proceed. Laplace inverse of 1 by s plus 2 times s plus 4 is equal to inverse Laplace of 1 by s plus 2 convolving with Laplace inverse of 1 by s plus 4. This we know from the table of Laplace inverses. This would be e to the power of minus 2t times e to the power of minus 4t. Not the multiplication but the convolution. So Laplace inverse of 1 by s plus 2 is e to the power of minus 2, and Laplace inverse of 1 by s plus 4 is e to the power of minus 4t. Okay, now let's apply the convolution. That would be integral from 0 to t of e to the power of minus 2u times normal multiplication e to the power of minus 4 t minus u d. Okay, now this we can combine e to the power of minus 2u minus 4t minus u. Okay, now let's combine this minus 2u minus 4t plus 4t, no, not 4t, 4u du, which is equal to 0 to t integral e to the power of 2u minus 4t du. Yes, this we can separate it out. 0 to t of e to the power of 2u times e to the power of minus 4t du. Now this would be a constant since u is not there, so which means we can take it out. E to the power of minus 4t integral 0 to t of e to the power of 2u du. Okay, e to the power of minus 4t. Now we can integrate this, right? E is e itself, so e to the power of 2u. Then we have to look at 2u, so divided by 2. Integral from 0 to t, which is equal to e to the power of minus 4t. Remember, this is outside the integral, and this would be e to the power of 2t by 2 minus e to the power of 0 by 2, which gives us e to the power of minus 4t e to the power of 2t by 2 minus 1 by 2. Now let's take e to the power of minus 4t inside. So we end up with e to the power of minus 2t minus e to the power of minus 4t divided by 2. So that is the Laplace inverse of 1 by s plus 2 times s plus 4. Okay, let's look at the second problem. Let's say we have to find the Laplace inverse of s by s square plus a square square. Okay, now using convolution we can say this is Laplace inverse of 1 by s square plus a square convolved with Laplace inverse of s by s square plus a square. So now Laplace inverse of this is 1 by a times sine at. Laplace inverse of this is cos at. Now let's apply convolution. So that becomes 1 by a, which is a constant, integral from 0 to t of sine a u times cos a times t minus u du. Okay, now see here we have sine a, that is this, cos b, that is this. Now we know this identity. Sine a times cos b is equal to 1 by 2 sine a minus b plus sine a plus b. So which means we can substitute this with sine 1 by 2. So this whole thing 1 by 2 sine au minus at minus au plus sine au plus at minus au, and finally du. Now 1 by a integral 0 to t of sine au minus plus au minus at plus sine, this and this gets cancelled and we are left with at, and this whole thing is going to be inside a single integral, that is du. This becomes 1 by a integral 0 to t of sine 2au minus at plus sine at. I missed 1 by 2, 1 by 2 du. Very easy to miss sometimes this. Okay, so this 1 by 2 is a constant, we can take it out. So this becomes 1 by 2a 0 to t of sine 2au minus at plus sine at du. So now what do we do? 1 by 2a 0 to, no, let's actually integrate it. What we get is minus 1 by 2a cos 2au minus at if we integrate this, and then plus u sine at 0 to t. Okay, now let's take care of the boundaries. So that becomes minus 1 by 2a cos 2at minus at plus t sine at. This is one part. Then minus, we get minus 1 by 2a cos 2au, u is going to be 0, so this will be 0 minus at plus 0. Let's take one more step. 2a, now what do we have? Minus 1 by 2a cos at plus t sine at plus 1 by 2a cos minus at. Now cos minus x is cos x, so we can write at. So which means this and this gets cancelled out and we are left with 1 by 2a if we remove the bracket. So times t sine, so that is the Laplace inverse of s by s square plus a square the whole square. Okay, take it step by step, don't try to jump steps. It's very easy to get miss out things. Okay, so now let's look at the next problem. Solve the integral equation f of t is equal to at plus integral of 0 to t of f of u sine t minus u du. right? So we need to figure out f of t. So let's use the convolution. So f of t is equal to at plus f of t convolved with sine t. This is nothing but the convolution. Now let's do the Laplace transform of both the sides. So Laplace transform of f of t equal to the Laplace transform of at plus Laplace transform of this convolution f of t involved with sine t. Okay? Now what? This is nothing but a by s square plus, now this convolution we want to convert it into a simple multiplication. So what do? We say Laplace transform of f of t times Laplace transform of g of t. I'm saying instead of g of t, it is sine of t. Okay. So which is equal to a by s square plus Laplace transform of f of t times, now Laplace transform of sine of t is 1 by s square plus 1. Now here also we have Laplace of f of t, Laplace of f of t. So let's bring it to the same side. So we have Laplace of f of t minus Laplace of f of t by s square plus 1 is equal to a by s square. Now what do? Let's take Laplace of f of t out, since it is common to both, and we end up with 1 minus 1 by s square plus 1 is equal to a by, so Laplace of f of t times s square plus 1 minus 1 by s square plus 1 is equal to a by s square. Now this and this cancels out, and now let's take this to the other side. So is equal to a by s square times s square plus 1 by s square, which is equal to a not square a times s square plus 1 divided by s4. Now let's split this. Let's split this. A s square by s4 plus a by s4. So what we end up with is 2. So a by s square plus a by s4. And now let's take a common out. We could have done it in a much simpler way also. 1 by s square plus 1 by s4. Now remember, this is the Laplace transform of f of t. What we want is f of t. So that would be the inverse of this. A times 1 by s square plus 1 by s4, right? Now a we can write it as it is. Now, Laplace transform inverse of 1 by s square is t plus 1 by s4 is p cube by 3 factorial. Again, you have to refer to the table. So that is applying the convolution theorem. That's it. Bye.